Well, let's just get started. Hello, everyone. Welcome to my Zoom talk. I'm Chase Mitchison, and working towards a PhD in experimental music and digital media. And as part of that work, I have developed an indeterminate sample sequencer in virtual reality. So I'm going to talk a little bit about indeterminate sample sequencing in virtual reality. So I wanted to design a way to perform and write music in virtual reality using an atypical musical interface. One of my favorite things to do with friends is play Dungeons and Dragons. Since my friends and I don't all live in the same city anymore, we play online using an in-browser client called Roll20. Roll20, when you want to roll a dice, you can use a menu to select the dice you want to roll, then click and drag your mouse across the screen. When you release the mouse click, 3D dice bounce around the web page and reveal what you roll. I find this interaction to be very fun. And we'll often just roll 20 or so dice across the screen just for laughs, because it also shows up on everyone else's screens. This is Ben Wyatt rolling a humorous amount of dice for those who cannot visualize why it might be fun. So I thought about this as an interaction for music making. I wondered what sort of data the dice would provide in a music writing scenario, and imagine them determining synthesis parameters, effects parameters, dynamics, tempo, and the like, but eventually decided on using them to select samples from a sample bank. This is all well and good, but when you select a sample, you have to have it play. So I thought, well, they'll just play when I roll them. Seems like a solid plan. So I put this plan into action and rolled the dice and heard the samples and then heard nothing, followed by more nothing, followed by even more nothing. I'd only triggered them to play once, and that was it. That did not make for great music. See, the thing about music is that it needs to play over time. So now I have to figure out how time passes in virtual reality, which is a surprisingly deep question. My first thought was to copy what every sequencer already does and make a playhead move across the screen and trigger playback of everything it touches. This stick you see here is my interpretation of a 2D playhead. They work incredibly well in a 2D environment, but lack the depth required for a 3D environment. So instead, I started with a tall vertical cylinder that expanded its diameter from the center of the stage to the outer edge of the stage and looped back. This was fine initially, but eventually demonstrated the need for its height to change as well. So instead of a cylinder expanding outward across the stage, I implemented a sphere that expands upward and outward across the stage. Now that I have the groundwork laid out to make a sequencer in VR, I can define what I want from the interface. Not only do I want to write music with a VR sequencer, I want to be able to perform with it and share it with those who are unfamiliar with experimental music, virtual reality, and musical performance. A traditional sequencer can select sections of music to loop, and I expect the same from this project as well. Furthermore, I expect to be able to generate multiple playheads to create multiple looping processes. This will increase complexity of the loops, generate interesting rhythms, and it expands the capabilities of typical sequencers. Since I'm using dice to select samples, and I'm specifically using dice from D&D, I want them to behave differently. There are 6 different dice to roll, so they should all play from different sample banks. And like my thought process for changing the 2D playhead into a 3D expanding sphere, I want to think about how spatial orientation of the dice determine the sequence of clips. I expect cases where some dice are higher up than others, and I expect to experiment with placement of the playheads and how 2 different playheads will play the same orientation of dice differently. Let's talk about the dice a little bit. As I mentioned earlier, the dice come in 6 different shapes: 4, 6, 8, 10, 12, and 20-sided dice. Here are some lovely purple and gold pieces from Dice Game Depot. You may notice this picture actually has 7 dice in the photo. It's because dice sets are commonly sold with 2 10-sided dice, so just ignore that. So because of the variety of the dice, I wanted a way for each of them to sound different. So I made the dice audio clip selectors, which really just means they can play back any audio clip in storage. I have 16 sample banks of 8 to 20 audio clips each. The spherical playhead is assigned a sample bank. When a playhead contacts a die, it provides information that tells the die from which folder to select audio. The die selects the nth audio clip in said folder, n being the die face which is touching the ground. So if a four-sided die with its fourth face touching the ground is triggered by the playhead to retrieve audio from the 10th folder containing audio clips, the die will play back the fourth audio clip in sample bank 10. This means the playhead and the dice are acting in tandem to trigger audio clips. The playhead asks for a specific sound bank, and the dice returns a sample at a specific location in that sound bank. To get technical here, I'm using a feature in Unity game engine called Unity Web Request. I'm very fortunate to have been led to this by a kind stranger on the internet forum, especially because they're changing Web Request on future versions of Unity. I'm using Unity 2019.1, and I believe on 2019.3, Web Request is already deprecated. Anyway, it's a neat feature where you can supply a web address to Unity via a C# script, and Unity will fetch the file at that address. I overlooked this at first because I'm not storing data at any web address, so it seemed irrelevant to my project. But that kind stranger on the internet informed me that I don't need to supply a web address and can supply a directory location instead. So I'm storing the sample banks in Unity's asset folder and asking Web Request to find every .wav file stored in the assets folder and organize them based on the folders and subfolders and files it finds. With this data, I can set up my own C# method called toll. Toll takes in a directory number and a file number. Calling the toll method this way allows me to choose a directory. Based on info from the playhead and a file number based on info from which die face is touching the ground. Now that we understand how the dice are functioning, let's bring it back to the playheads. I chose spheres because they're omnidirectional. I discussed this earlier when describing the change from a 2D playhead to a cylinder to a sphere. I intended on the height of the dice to change, so I wanted something that could handle expanding in any direction. I also wanted musical functionality from the playheads. In a digital audio workstation, you can control things like tempo and time signature so the playhead correctly plays back your music input. To do this in the VR sequencer, I've created a menu for the playheads, also known as time spheres, which controls different parameters. Each time sphere can have its parameters edited. Layers are a setting in Unity Layers are a setting in Unity that group objects. I'm using them to group time spheres that select sound banks. If a time sphere is set to layer 1, the D4 will read from sound bank 1. If the layer is set to 12, the D4 will read from sound bank 12. So this one-to-one mapping is true for the D4. But to avoid every dice playing the same audio, I set the other dice to different sound banks. So layer 1 means D4 is on sound bank 1, but it means D6 is in sound bank 2, and D8 is in sound bank 3, etc. up to 20. The minimum and maximum size enable changing the duration of loops with time spheres. A minimum size of 0 meters and a maximum size of 150 meters will take longer to traverse than a minimum size of 0 and a maximum size of 20 meters. Using this parameter is great when you want to make interesting rhythms and works well with the speed parameter. Speed also affects tempo, which is similar to duration. With duration, what I'm saying is the length of this phrase is 4 bars. With tempo, I'm saying these 4 bars take 4 seconds to play back. So if I have 2 time spheres with the same min-max size, but different speeds, they'll loop at different rates. Reverse shrinks the sphere from a maximum size to a minimum size instead of expanding. This reverses the playback order of the dice that you've arranged. and is basically retrograde motion. Finally, the spatially interesting functionality is the placement of the playhead time spheres. A time sphere hangs in the air, ignoring gravity, and can be placed anywhere within arm's reach. By choosing the placement of the time spheres, you can use layers and size creatively to take advantage of placement of dice in the area. Taking a look at this photo from movement 2 of primitives, hold, you can see how the size and placement of the time spheres controls playback in a spatial manner, where I have 3 time spheres triggering one object, 3 triggering another, 2 triggering another, and then 1 triggering all 3 objects. This, I think, is very spatially interesting. So I was delighted once I got the playback working well with the dice and the time spheres, but I knew that there was still something missing. If you take this project and look at it from a bird's eye view, you'll notice this project is still quite similar to how a traditional playhead works, because I'm not taking height into account. I got to wondering what I could do to add height to the mix. I thought about dice floating in the air, but that proposes a problem of retrieving them. I thought about building planes and columns raised above the main stage, but that proposed the problem of reaching the second and third levels. It also showed me the problem that a stationary height change doesn't affect the sound enough to warrant developing it. Finally, I came across a YouTuber, Sebastian Lage, who was generating terrain in Unity at runtime. He was using it to make infinite mountainous terrain, but it gave me the idea to trigger random terrain changes on my stage. So following Lage's teachings, I used Perlin noise to generate a map that changes height based on noise patterns. Generating terrain at runtime creates hills and valleys that influence the dice arrangements and can cause dice to fly in the air, which means I don't have to pick up every die and roll it again once I have a complex pattern laid out. Creating hills also raises and lowers the entire plane that is the stage. So earlier I mentioned the time spheres were stationary in the air, unaffected by gravity. Due to this, if the stage rises its height, it can surpass the height of a time sphere. Changing the way the clips through the time sphere changing the way the stage clips through the time sphere changes the qualities of the sphere. Check out this photo from movement 3 of primitives, release. You can see how shallow the time sphere bubbles are because their origin point is well below the stage. Now fewer dice can fit inside the sphere, thus changing the musical output. Finally, now that I'm including height into my 3D sequencer, what am I supposed to do with it? Well, how about triggering audio effects to change? I'm using Unity's native plugin API, which includes Unity's own audio effects plugins built in C++. Each of these plugins has the ability to expose parameters to scripting. This means if I want to change the feedback of the delay plugin, I can expose it to scripting and write a script that accesses the feedback. From there, I can change it at runtime and have command over the audio effects. I started this project with that in mind and even tried it, but found that doing this can be very computationally expensive and cause frame rates to lower. That's when I learned about snapshots in Unity. Snapshots act like presets to plugins. You can select a mixer with an audio effect, create a new snapshot, edit the effects parameters, and call that snapshot at runtime. This is much simpler than exposing parameters, and I've had a much better success with maintaining frame rates using snapshots. Each effect chain I have in the sequencer is built into the scene. There's a scene with echo and chorus, a scene with reverb, a scene with a resonator. I've made several snapshots for each effects chain that are triggered by terrain changes. When I click the button that changes the terrain, the snapshot changes to a random other snapshot over the period of time it takes for the terrain to stop changing. This produces an effect that's like transitioning between sections of a piece of music. When listening to primitives, you'll notice the terrain changes cause audio artifacts in the music warping and stuttering before settling into a new effect that drastically changes the sound of the previous setting. You may notice the title of this presentation starts with the word indeterminate, but I have not mentioned it even once. Well, we finally made it to the indeterminacy section. To make music with the VR sequencer, you have to take a chance by rolling dice. This is the first step in making stochastic music with the VR sequencer, a random number generator. And in this case, we have 6 varieties. Additionally, they all have blank faces, so knowing which face the dice are on is insanely difficult. Each of these dice are triggered differently by time spheres based on the layer of the time spheres. You can know which layer is triggering the dice, but you won't know what audio clip will play based on the layer alone, since you don't know what face the die is using when you're calling the sample. Initially, using space to your advantage when composing produces a predictable result, right? So I could just put 3 things in a row and I know they're going to play in that order, and it's pretty predictable. It's going to loop on in. But adding more time spheres and editing time sphere parameters leads to an indeterminate outcome. So I can have those 3 triggered in a row, but if I add another time sphere, maybe they're going to trigger only slightly out of order. And then we get to hear 2 different versions of that going over and over and over. And you're not really sure what that's going to sound like when you first play it. And same thing with just making and rolling new dice. So this is made more challenging by terrain changes, which cause the dice to roll and hop and raise and lower. Terrain changes also aren't always drastic. So sometimes they change just a little and the dice don't even roll around. So you can't always rely on formal changes when using the terrain generator, but it is a good way to try to mix things up. The audio effect snapshots are chosen randomly, but there are fewer possibilities of outcomes in this category. However, a drastic change in effects can make a drastic change in terrain seem even more impactful. So much of the music making process with the VR sequencer is ultimately indeterminate, and that's what makes it so much fun to play with. So what's it like to use and perform? Well, it's actually quite exciting to perform and write music with the VR sequencer. When you start creating objects and throwing them around and editing parameters and changing the terrain, the music just happens naturally. It's an incredible exercise in listening when performing with a VR sequencer. Your instinct sort of takes over when you hear something you like or don't like, and you know when to change what is happening or when to wallow in it. Something not present in the Primitives music videos is the sense of scale. The dice are huge. They're like 2 meters tall. So you feel like you've been shrunk down to a tiny size. But you can also throw the dice very far, which makes you feel very powerful. So it's what I imagine ant strength is like. And now I'm imagining the ant scene from Honey, I Shrunk the Kids. So it's like that. But really, the music making is instinctual for me. Maybe it's because I developed it or already know the controls. I'm not sure, but I love it. So let me show you the first-person view of this thing. Here we have the object creation menu. To get here, you press the menu button on the controller. You can just aim your controller at the button you want to click, pull the controller's trigger to select what you want to generate. Let's generate a D4. I love the way the D4 spawns and slowly falls. It's very satisfying to watch. So we've made one, but we need to interact with it, right? So let's pick it up and throw it. Don't mind the magenta controller. I'm having a material related issue there. To pick it up and throw it, just touch the die with the controller, pull and hold the trigger, and now you're holding it and can pick it up. To throw it, just let go of the trigger. It should feel the same as throwing a ball. That video is a little harder to watch because of the first-person camera and my head shaking. I apologize. I've done the best to minimize it, but in some cases, it's kind of unavoidable. So we got dice laying around. We need something to play the audio So let's go ahead and make and edit a time sphere. Select the time sphere on the menu that we saw earlier to generate a new one. Once it's generated, you can open the edit menu by grabbing and holding the time sphere and clicking the menu button again. So you'll see this new menu pops up. Here you can adjust parameters that you want, close the menu with the menu button, and release the time sphere. So we picked up and threw a D4 earlier, but you cannot throw the time spheres. Like I said earlier, they're not affected by gravity. So you can only pick them up and release them. They'll just stay static wherever you let go. To traverse the terrain in the VR sequencer, we use a teleport function that's found in many VR games. I quite like it. I think when you're playing VR and you're teleporting instead of walking, or using a character to run, that the motion sickness is less likely to happen for me personally. That might not be the same for everybody else, but it's what I'm using here. It's what I enjoy because I can sit in a chair and play it. I don't have to move. So to teleport, you press on the trackpad in the direction you want to teleport and select a new location. You'll see a little arrow go out and hit the ground, a little yellow arrow. And wherever it's yellow, you can teleport to. Wherever it's red, you can't jump to. That's fine. It just won't let you go. So you'll see that at the very start of this video is really quick. Then you'll see the terrain changing, drastically, I might add. To change the terrain, you just click the grip button on the controller. Once you let go, it just changes. It does its thing, and maybe it's chaotic, and maybe it's not. So here's the teleporting and the terrain. And I really love when the terrain's bouncing like that, everything's flying. I tried to get like the craziest one I could find. And I think it's even more fun when, you know, at the end there we had a little D12 sort of slowly stepping around and kind of falling back into place. It's a lot of fun to watch that stuff. And because of the scale of everything, it's just incredibly enjoyable. But those are the basics of the controls and functions in the sequencer. You can make dice, you can make spheres, you can throw the dice, you can edit the spheres, you teleport to chase things around and pick them up and throw them and mess with them. You click a button and the terrain goes haywire and the audio effects start changing. And that's it. It's a lot of fun. So I just want to thank everyone at LSU and CCT, all my professors and peers and friends. I've had such an amazing time working and learning with and from everyone involved with the EMDM program. It's been an honor getting to know everyone, and I'm very fortunate to have come to LSU. So thank you.
But Case, you know, what good is a recital without applause?
Thank you, Ken. I'm trying to figure out this screen share. There we go. Stop share. Hey, I'm back.
Well,
I'm just going to unmute. Well, if anyone wants to talk, feel free to unmute. Nick is joining us, but he missed the brunt of it. So yeah, we're going to open it up for Q&A now. So if anybody has any questions, let me know. In fact, I assume everyone can unmute themselves, right? Let's hope that's the case. Cool. All right.
Yeah,
well,
they can. Chase, can I ask a question?
Yeah, go for it.
So one thing I was curious about was the background background image. I don't know if I'm referring to it correctly, but like the overhead environmental image in the demos you showed. Do you think that being able to change, like it was like a cloudy kind of like
Yeah,
stuff.
yeah, it's the skybox is what that's called.
Oh, okay. Do you have plans, or like can you foresee any kind of concept where maybe changing that environment can affect your sequencer in any way? Because you put a ton of focus into the stuff that, you know, you have a really good case for things that would affect the sounds. But what about some of the things that maybe seem more ornamental, but maybe surprising that it could affect?
Yeah, I think that works well. I mean, that's a great idea for the skybox itself. An issue with that is it's just an image. So it's basically just the inside of a cube, and it's 6 images that make it look like some clouds. But what you could do, because what most video games do is they make weather systems for their games. They make time pass. They make the sun go up and down, and the moon comes out, you know. So having some sort of system like that would be incredible. You'd have to do, I don't know how large you'd want to make it, and I don't really know how much control you'd want to give the user over it. But that's absolutely possible, and I think a better application for that is to use this project as an installation instead of a game or something. But as an installation, allowing people to come by and maybe mess with the weather or something, that would be a really interesting way to take it.
Yeah, that's cool.
Mm-hmm.
Chase, hey, great job, first off. Secondly, I noticed in the videos that you shared with us, there's like a top-down view, or I guess in game terms it's called the God view, where you can see everything down below. Mm-hmm. Is that something that, how did you implement that? And is that something that you would allow someone in VR to choose between the first person, the cubes are in front of you, or the first person overhead view?
You know, so implementing it was a matter of adding a second camera, and in Unity, cameras are set to layers. So I have my VR camera, and it's set to layer 0, and then I made the other camera, I made an orthographic camera, just pointing down, and set the settings to follow the little green character. And I set the layer to 1 so that when I did any recording of it, I could still see through the VR goggles, but what everyone else was seeing was that orthogonal camera. I much prefer that to demonstrate what's happening. I don't personally like watching videos of people playing in VR from the first person perspective, because my eye gaze is so different from what theirs is. And so if I find myself looking somewhere and they start moving their head in a sudden direction that I wasn't expecting, that kind of throws me out of whack. It kind of makes me dizzy. That drives me crazy. So I prefer having a third-person view. So I made the third-person view for the sake of the music videos. I didn't think people would want my head shaking and all the stuff wobbling when I was picking things up and throwing it. You can't really, when you're in there doing it, you don't notice it. It doesn't feel bad because I'm sitting in a chair the whole time I'm doing it. But so as I showed the video of me picking up a D4 and throwing it, and the amount of head wobble in that is a lot for such a small short video that I think it's not really worth it to display that. But if a user wants to display that instead of the third person, that's fine. And if they'd rather play in third person, it'd be a little hard, but there's no reason they couldn't. I kind of realized that really just yesterday when I was editing those videos. So I was like, it seems like it'd be fun to do in third person as well. But I kind of like when you're in first person and the dice are so tall and you get to pick them up and throw them, it doesn't seem as fun to me to do it in third person, but yeah, it could be done.
Cool, thanks.
Yeah.
So Chase, this is Steve.
Yes.
So I spent a little time this afternoon watching the videos, and I found it's a really interesting concept. I found the music to be stunning.
Oh,
that
thank you.
What you were able to generate, it just sounded great.
Thank you very much.
It was lush. It was mysterious. And there was some linkage. I mean, there was some obvious linkage between what you saw happening from a third-person perspective and what was going on with in terms of the event triggers and things like that.
Mhm.
It wasn't. What I liked about it was it wasn't visually one-to-one obvious, especially as you started layering more things and the sounds became more complicated. But yet it was still, you could still see that there were connections, and you could, with time studying it, you could see how the spheres were interacting.
Mhm.
But you answered the question that I was going to ask you in your talk.
Mm.
But I'm gonna ask you, do you think that your solution was actually good? The thing that always got me was when you did a terrain shift,
Mhm.
the sound environment, the sound world shifted radically and suddenly. And it was from a listening perspective, it was very, to me, it was very disruptive.
I agree with that.
And it created a sense of musical discontinuity that I'm not sure what, it has some challenges. So I guess but you answered the question as to why you were doing that, because that's why you were doing that. So the question then is there, how do you see the cost benefit analysis between the computational time that you're saving versus the benefit or detraction in the music in the end?
I think I would rather do the exposed parameters and have, because I had it mapped to with the terrain. There's noise maps, and they have different parameters. They've got scale, persistence, laconarity, X and Y offset. You've got all these parameters that you can say, hey, when that's changing, make the feedback and the delay line also change. And so you can map them to these really neat ways. And I would much rather do that. And I'm willing to bet that a very proficient composer or proficient coder could achieve it. Someone who actually knows C# programming very well could achieve that. But I think with what I was doing, given the limits of my knowledge and time, frankly, the snapshot version works better for now, I guess. It's more of a for now thing, I think. I think it's, in the long run, there's no reason you couldn't do both, I guess. But if you're using the snapshot, like you're saying, the discontinuity, there's a lot of clips that I didn't put out because of something like that. So a lot of the music I made has too much of that going on, or I'll find something, I'll go, oh, that's really cool, and then I'll immediately skip it. I'm like, why did I skip that? This is bad now. And it just sort of, it doesn't fit. But I think taking the snapshots and sort of blending in a way to figure out how to transition them better or smoother or slower or something, I think that's maybe a step for my next process. But I think ultimately, someone who knows maybe scriptable objects and C# and just Unity in general could probably point me to a better way to get the individual exposed parameters to work better. And I think implementing a mapping system with the Perlin noise would ultimately deliver a more interesting product. So.
Well, I'm glad that you said that, because the next question that I had that I thought would be I have two thoughts that I wanted, or two kind of future directions that I want to get your thoughts on. One would be, I mean, the terrain shifting is a wonderful. The first time it happened, because it was so sudden and because it just was like, wow, something's happening. And then I saw the terrains were shifting, and I thought, oh, that's really kind of cool. That's like really cool. And so, but what I was thinking was, what if the terrain was constantly changing,
Mhm.
but at just a very at a very slow at a slow rate, so that what you're looking at is over the course of a 6-minute gameplay, there the terrain is constantly shifting, and it's then transformed. It creates one more layer of transform, of shifting the way that the looping is happening, and to
Yeah.
do it in a quasi-predictable way.
That it's funny you say that, because I was thinking when I was editing my clips, there's a lot of times when I'm sitting there and it'll be 5 minutes of one loop, and just because of the time it takes to set up the next loop, when you're in there, which is kind of a weird thing on its own, but I'm sitting there editing these clips and I'm going, why wasn't I just constantly pressing this button? When you get to, you might reach something that you like the sound of, but to listen to it for 5 minutes is so grating. So, you know, it's not something I'm not sharing those clips, you know, because listening back to it, it's like, that's not really worth it. But yeah, I had that same thought of, if I could just mash the button the whole time and just keep the terrain changing, and then that way it's going to seem kind of less tedious and monotonous, but doing that would still lead to the discontinuity. So I kind of like that idea of just having it gradually change the whole time. And
I mean, but if you're, I mean, what I liked about when the terrain changed, I loved how the dice were, I didn't know that that's what it was. I knew these were objects. I couldn't really tell what they were, but I could see them move and shift. And I thought that was just wonderful. So I could envision, especially if you've got this more continuous, you know, you're dealing with the exposed parameter sets directly, then you could have kind of like a rolling ocean type of noise going on, and every so often you just kind of thump it, and it does something kind of really interesting, like
a drop of water hits it, and
exactly. But the other thing also that I was thinking about, what if there was somebody else in there playing at the same time? You know, so I'm thinking that this would be, I could see that, especially if you're thinking of it as an installation environment, having an environment that was multiplayer you could create a lot of crap, but you could also create some really interesting things.
Yes.
And especially if you're thinking of it in a performative way, then people could practice and work together and collaborate on what these pieces would be. And I think that as a musical experience, it would be really stunning.
Yeah, I love the collaboration, the multiplayer aspect. It would require some way to delete things, which I haven't been able to implement yet. I thought I had code that would make it work, but it didn't quite work. But being able to, if you have so many people working on it and it does sound like crap for a little while, you really want to go in and say, hey, this whole region here needs to be deleted, and we can start kind of fresh and get things moving again.
I had a parallel. I'm glad you said that about deleting, because I was thinking, what if these, you know, I wasn't sure if these things were just perpetual, or how you would kind of turn them off. And I discovered that you were turning them off by throwing the dice out of the spheres of
That's
influence.
The closest I came to it. In fact, if you can throw them off the stage looks pretty enormous, but there is an edge. You can throw them off and they'll just delete immediately.
But the other thing that I was thinking of was that things could simply time out or age out.
Oh,
and just die. And that,
wow, I hadn't thought of that.
And that, so that as you set up these processes, you could set something up to last for, say, 100 frames or 200 frames or however, or it could be a function of the distance that you've thrown it. I mean, there's all kinds of ways that you could kind of parameterize it. But I think having something like that would also it would allow for this kind of evolving, natural kind of engagement.
Right. Yeah, it seems that version of it seems a lot more organic than what I've got, and I think that's a really excellent step in the right direction.
Yeah. But I thought it was wonderful. I loved how the little object was throwing things. You could, even though I know it, you couldn't see any arms or limbs throwing things. You still got the sense of, yeah, it was being chucked over here and thrown over there. You really got a sense of that. I really enjoyed that.
That's great. I was a little worried about that. I'm glad to hear that. This is good news. Thank you for that.
Sure.
So I had just one little thing, if no one else does right now.
Sure.
All right, cool. So Dr. Beck kind of touched on, I was going to ask about some of the potential multiplayer options. Another thing that kind of reached out to me was like having the possibility in a future version where you could like maybe adjust the weight of the blocks, so one goes farther than the other. I don't know how easy or not that'd be to implement.
Oh, you can. You're talking about the dice? Like
so
some dice are heavier than others or something?
Right.
Yeah, that's cool.
Way to interact with it.
I hadn't thought about weight, but I'd thought about materials. In Unity, you can use physical materials. So I could put on something that has high friction, or something that bounces easily, so that you could just chunk it and it just bounces and bounces and bounces. And that would have a similar effect, but you can actually do weight, and I kind of just hadn't thought about that. It maybe because of the way I'm generating things, I wasn't thinking about it, because I've just got sort of a prefab that's instantiating. And I guess, yeah, it seems like more of an in-depth thing of maybe deciding all the 6s weigh more than all the 5, or all the 4s, and all the 4s weigh more than the 8s or something. But that would be interesting to see how they throw and how they interact with each other, but also to what the weight does to the audio as well. Or I'm just thinking of like, could the weight change, I don't know, these audio effects as well, or is there some sort of inertia or momentum I could use from that even? So that's a pretty excellent thought.
I have a question about how it relates to a step sequencer.
Oh, sure.
How do you think it's different, and how is it the same? And have you ever considered quantizing the timings of the when the expanding spheres strike one of the dice?
I had not considered quantizing them. As far as the similarities go, I kind of mentioned this in the slides about the bird's eye view before I changed the height, before I added the terrain adjustments. When you're just looking at it from the top down, you'll see the sphere sort of expand. And while it's expanding in 2 dimensions, you could still remove one of those dimensions, right? And see that, well, it's going right, or well, it's going left, or it's going up, or it's going down. It's just sort of, you pick a point and it's headed in this direction, right? So in that sense, where in a sequencer you have a playhead that is a point, and then it's usually a line, demonstrate however many tracks you have, it's a line, but it's still just a point in time. The similarities are sort of, there's a point in both of them, and we're going across in a linear fashion across a physical space, basically. So in the traditional sequencer or a DAW or something, it's like a virtual piece of tape, we're just sort of moving across this virtually physical piece of tape. But I think they start to differ when I did introduce the terrain, but only in the sense of changing how much they're looping, right? So I sort of showed that section where the stage cuts through the spheres, and it's a really shallow bubble. And it's still the same in that it's reaching a point in time and expanding and passing through physical space and reading what's there. But it's used part of the world around it to make the playback different. So I'm using the environment to change the output, which I guess if you broke that down to some simpler sentence, you know, you're still in a DAW. When I turn a knob, I'm using the environment to change the output. But I guess more. I don't know if I want to use the word organic or not, but the indeterminacy of it sort of strikes me. I suppose I would think that in a DAW, you're not going to have that sort of indeterminacy.
Well, now that you've made all these advances and you've learned all this stuff, what are your thoughts now on the Tunity project?
On the Tunity project, well, I thought about this project for a little while because it appears to work. It appears to do what it's supposed to do, right? And like I said, I'm still pretty much I'm not incredibly proficient at C#. I know my way around it, but programming for Unity is kind of a difficult task. And to see the Tunity project do such an excellent job, one of my favorite things they do actually is, I guess it's the, what do you call that? They can basically, I think they call them functions. They can basically take a series of events and put it into a box. And then you can kind of shrink down and go into that box and mess around with stuff. And then you can kind of jump out and change the size and scale. I'd initially thought about doing something like that for this project, where I was taking objects and changing the size of them, or like going inside of them and manipulating them to sort of do some sculpting of sound effects. And that kind of fell through, but I noticed that Tunity seems to be able to do something like that. However, I think the VR sequencer is, I'm tempted to say newcomer friendly, because it boils down to generating an object and throwing it somewhere. And that's all you really have to think about. With Tunity, you're doing so much in the way of DSP that if you don't really know DSP, you're not really understanding what processes you're doing. You don't know why you need what objects. You just might have a hard time connecting objects, right? And so you're sort of building sculptures in Tunity. So it's a little different in that aspect. I think if you were to get a gamer, I'm just going to say a gamer, and give them Tunity and give them this project, I think their ability to make music will come more naturally in my project. And so that's more what I'm looking for, is allowing access to people who aren't familiar with making experimental music, the ability to make experimental music, kind of without thinking too hard about it.
I mean, I guess one key difference is I've only seen Tunity used sort of in a live coding situation, although I haven't looked into the project recently, so they could be doing other things with it, but definitely when they presented it at 9, it was very much like live coding.
Right. I guess that's kind of what I mean when if you know your way around experimental music and DSP, then you'll be able to handle Tunity and you'll know what you want to do with it and how to connect objects. But with mine, I think anyone can just kind of create something and let the music happen.
I've got a. Oh, go ahead, Yeon.
Well, I'm just curious about other like feedback. Have you thought of like haptic feedback? Because VR is just so immersive. So I was just curious, like you have like tactile transducer or using like a simple sensor.
I haven't done that. Part of the project was to use just the consumer gear that comes with a VR set, basically. So I've got the HTC Vive and the 2 controllers that come with it, and then the sensors. You can see one of the sensors right here. So without using external hardware, I wanted to see how much I could do. But with the haptic feedback, I don't know if these controllers can, but I know some controllers come with like a rumble pack feature. They'll vibrate or something. And I don't really know what I would use to apply with it. I mean, if you're picking something up, maybe you get the feedback of contacting it. Or maybe feedback when you select a menu item, but I don't know that I would need that for this specific one. But if I were to move forward and make it an installation rather than just some software that you can share on Steam or something, then I would rather do the more immersive version of it where I've got some sort of sensors and feedback going on. Because I think when you invite a bunch of people into an area like that and you get everyone making music together in that environment, any amount of feedback you can provide is going to enhance the experience. So I think for that application, it's much better suited. But for this specific application, I was trying to just stick with bare bones gear. What if you own a VR set, then you can play this at home, you know.
Yeah, because also you mentioned you want to try other materials. So I was thinking like different weight,
right?
Using simple Arduino. Yeah.
Yeah. So that would be very neat and a lot. That's an entire other dissertation, I think.
Yeah.
So
Jess, I have a quick question for you, and,
Yes.
and then I'll let Jesse talk, and I'll back off.
No. Someone else interrupt him.
Well, I really loved the Bug's Life view of it, and I was wondering if you managed to chuck the same die repeatedly, does it emit the same loop every time?
No. So a single die, if there's 4 sides on it, there can be 4 audio. There can pretty much be 4 samples. I think I hear somebody. There can be 4 samples inside that die, but the time spheres have layers attached to them. So if there is, I'm trying to think of quick maths. I probably don't even need the quick maths. So if you have 4 samples, and then you have
the 4 with the beat. I mean, you don't have to do any math at all.
Right. I'm trying to think. I keep hearing this like weird feedback of my own voice, and it's stopping my mental process. So the layer of the time sphere is going to determine what sound bank to pull those samples from. So if you have a time sphere on layer 1, you can roll that 4-sided dice as many times as you want, and it's only going to play 1 of 4 samples, but it's not always going to play the same sound.
Gotcha.
And then when you change the layer of that, you're going to get 1 of 4 new samples. Gotcha. So you can have, and there's 16 layers. So what is that, 90? Oh gosh, 90? I'm not gonna do any real math on here.
Well, Jesse adds real good. You can ask him.
You actually have led right into what I wanted to ask about. So the one thing you haven't addressed yet musically is the composition of the sound banks. Like, you had to create sounds to be able to put into the sequencer, but your sequencer doesn't work like a normal sequencer. So, I mean, what was your approach, or what did you find when you were trying to create sounds that would work be able to perform with or compose with once you finally put it into your sequencer?
what is that? What is that saying? When you a good artist borrows and a great artist steals, something like that. When my very first samples that I put into it were my own samples, and they were like little guitar chords, and they were like clicks and clacks and little just tidbits. I put them in, and you could make some music, and I kind of thought it'd be really interesting and percussive and exciting. It was so boring to listen to, and the sounds were so dull, and they were so quiet, and they were just it just wasn't great. And then sometime around Christmas, Ableton was like, oh, hey, do you guys want like 10 gigs of Music Concrete samples for free? And they just emailed all these samples out. So I've got like Pierre Schaeffer, Luke Ferrari, Bernard Parmigiani. I've got all these like great samples of all these like electronic music masters. And that's what I put into the game. And immediately the music sounded amazing. And I thought, well, that was the secret, right? That you need start with a good source, and then you can have good music. Seems, to me, the most simple. And then I kind of realized I needed more samples. So I spent a few days, I guess, going through my really old music from like 10 years ago, and just finding old songs that I was nostalgic for or liked or whatever. And I just cut up my own clips and I put them in, and they actually worked. I found that when you have something very melodic and rhythmic, a lot of times it's not going to work as well as you might think it will. So the melodic rhythmic songs are going to produce something too recognizable and too repetitive when you're writing music with it, so that you'll hear it once or twice and you'll go, okay, I get it. And then it keeps playing and you're kind of like, I don't like that anymore. It gets old very fast. So a lot of the noisier stuff that I had, I just kind of cut it up into small chunks. If it was melodic, I'd do 2 or 3 notes at a time. And then I put that in there, and I found that the noisier, I guess the noisier my music was and the noisier my source was, then the better the outcome was. So it's kind of interesting that it's really down to, good source and less recognizable, I guess, because noise is not typically recognizable. When you hear a melody or something, you can hear the intervals and what's playing, but when you get to a point of it being just kind of a mishmash of cluster chords or something, no one's going to pick that out and be like, oh yeah, cluster chord, nice. It's people are like, oh yeah, I like that arpeggio that they just did in the major key, nice. When you start hearing those like really recognizable ideas, it kind of takes you out of the music a bit and kind of makes it just fall a little flat, I guess. So anyway, composing was a lot of fun. Any other questions? All right, I'm going to take that as a no. Oh, there's that whole chat. I haven't even been paying attention to chat. Cool. Well, I want to thank everyone for coming out. Thanks, I see my dad and my brother are here. That's awesome. John is here also. Y'all don't know John, but he's working on brain-computer interfaces, and hopefully he can do some music stuff with that one day. Anyway, thanks everyone. Good to see you all, or at least see your names.